Good morning, class. I would like to start our day with full of interactive discussions and wonderful thoughts and ideas. So, the journey begin. All together, let's dig in the Earth's layer. But first, we have to read our learning outcomes. So, one, describe the structure of the Earth's interior. And two, identify the layers of the earth. So you have the crust, the mantle, and the core. And the last, explain how the use of models can be used to represent a concept of Earth's layer. Now, let's have a quick review or a look on a continental drift. So, as you can see in the picture, this is how Pangaea is. So, continental drift. Alfred Wegener theory that the continents were once a single supercontinent called Pangaea. So all composed of land. So over time, this supercontinent slowly broke apart into what we have today. So plate tectonics. So this theory of plate tectonics, the crust is broken up into sections, pieces that move on top of the liquid mantle. So as you can see in the picture, there is a broken lines. So these sections are pieces of crust now are called plates. Okay, so what are those plates? So as you know, we have seven major plates on the earth that are moving extremely slowly but continuously. So those seven major plates are Eurasian, African, Australian, Indian North, American, Pacific, Antarctic, and South America. Now, we have two main types of plates. So what are those? Oceanic, which comprises of all the oceans. Then we have the continental. So continental, all parts of the land are continental. Okay, class, I hope it is clear to you. Now, convection currents. Convection cells in the mantle move the plates. So, hot in the center, less dense magma rises up due to heat. So, when the magma reaches the surface, it then cools and sinks back down, creating a circular pattern of movement. Okay, again, hot and dense, less hot, more dense water. Okay, now, which of these diagrams show the layers of Earth? So explain your reasoning. So if you choose A, B, C, or D, then try to explain why you choose that diagram. Now, as you can see, we have here the picture of a hard-boiled egg. So this can be also used as a model that represents the Earth's layer. Okay, take a look on this. Consider that the shell of this egg is the crust part, and the egg white is just like the solid rock mantle of the earth, and the egg yolk represent like the molten outer core and the solid inner core of the earth. So at least you have now the idea on how the earth's layer looks like. Okay. So any question, class? clarification? So if there is none, then let's proceed. Okay, so we have here the different models that describe the Earth's layer. So if I am going to ask you to make or create a model that describe or represent the Earth's layer, then you can also do it on your own concept. You can design it on your own concept as long as it describes the Earth's layer. Okay, so I hope it is clear. Now, we will discuss the first or the outermost layer of the Earth, which is the Earth crust. So it is described as a thin shell on the outside of Earth, accounting for less than 1% of Earth's volume. It is the top component of lithosphere, a division of Earth's layer that includes the crust and the upper part of the mantle. So the lithosphere is broken into tectonic plates that move and allowing heat to escape from the interior of the Earth into space. So again, class, we will dig in more the Earth's layer. So now we will proceed to the next layer of the Earth. But before that, we will try to know what are those two distinct types of the Earth crust. So we have the oceanic, which is 5 kilometer to 10 kilometer thick and composed primarily of denser, more mafic rocks such as basalt, dial base, and gabbro are found here. And for our continental, it has 30 kilometer to 50 kilometer thick and mostly composed of less dense. So more felsic rocks such as granite are also found here. And mind you, I would like to stress this out that most earthquakes occur within the crust. Again, most earthquakes occur within the earth crust. Okay. Now, we will move on to the next layer of the earth. We have the earth's mantle. So we will try to discover what is the composition of the earth's mantle. It is a layer of silicate rock between the crust and the outer core. It has a mass and thus make up 67% of mass of the Earth. It has a thickness of 2,900 kilometers, making up 84% of the Earth's volume. It is predominantly solid, but in geological time, it behaves as a viscous fluid. Partial melting of the mantle at mid-ocean ridges produces oceanic crust. And partial melting of the mantle at subduction zone produces continental crust. So this is how it was broken into. Okay, so the lower mantle, so middle layer, it is very thick layer. Molten rocks are fluid and moving in a circular motion called the convection current. So again, class, we are now in the lower mantle. So again, it is described as a very thick layer. And of course, molten rocks are fluid and moving in a circular motion. Okay. So let's proceed into the Earth's outer core. So it is a fluid layer about 2,400 kilometers thick and composed of mostly iron and nickel that lies above the Earth's solid inner core and below its mantle. So again, it lies above the Earth's solid inner core and below its mantle. So its outer boundaries lies 2,890 kilometers beneath Earth's surface. So, are you still with me? So, okay, so now let's dig into the most exciting part of the Earth's layer, which is now the inner core. So the innermost geologic layer of the Earth, it is primarily a solid ball with a radius of about 1,220 kilometers, which is about 20% of the Earth's radius or 70% of the Moon's radius. So we have here some list of elements comprises almost 99% that makes up the earth crust. So to name those elements, we have oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium. So try to look at the table because it's stated here, their corresponding percentage by weight of the earth crust and of course the percentage of atoms that is present on these elements. So again, we have here the list of elements that comprise the making up of the earth crust. So class, is there any questions and clarification? So I hope you understand. So if there is no question, then let's move on to the next topic.